2.2 now, if you want to follow along in your textbook. 2.2 starts on page 37, and we're going to start with our properties of equality. A lot of these might seem familiar to you. They're things you use when you solve algebraic equations, but we are going to be using these as justifications as we get into our proof writing. So it's important to know the formal reasoning and formal definitions behind them. So it says let A, B, C, and D be real numbers, and the addition property of equality states if A equals B and C equals D, then A plus C equals B plus D. In other words, if you have equivalent values like C equals D, then you are allowed to add those equivalent values to either side of an equation. Right? Just like when you're solving an algebraic equation, if you add 5 to one side, you have to add the same value to the other side. Subtraction property, same idea. If A equals B and C equals D, then A minus C equals B minus D. If C and D are equivalent, then you may subtract them from either side of an equation. Multiplication property, if A equals B, then C times A equals C times B. Again, you may multiply equivalent values on either side of an equation. And division property, if A equals B and C does not equal 0, then A divided by C equals B divided by C. Again, you may divide both sides by the same value. So those should all be pretty familiar. Those are things we use when solving equations. Substitution properties should also sound familiar to you. If A equals B, then either A or B may be substituted for the other in any equation. Again, if you have equivalent values, then you may replace one with the other in an equation. Reflexive property of equality and congruence. What this means is this can work for equations and statements of congruence. So reflexive property basically says something equals itself, like A equals A, right? 3 equals 3. -1 equals -1. But this could also be used with congruency statements like segment DE is congruent to segment DE, or angle A is congruent to angle A, right? So things are congruent to themselves. Symmetric property of equality and congruence says if A equals B, then B equals A. In other words, your order can be switched. If X equals 2, then 2 equals X, right? Order there does not matter. Same thing with congruency statements. If angle D is congruent to angle E, then angle E is also congruent to angle D. Your order can be changed. Transitive property of equality and congruence says if A equals B and B equals C, then A equals C. In other words, if two values equal the same thing, then they are going to be equivalent to each other. If A equals 2 and 2 equals C, then A equals C, because they both have a value of 2. Or with congruency statements, if angle D is congruent to angle E, and angle E is congruent to angle F, then angle D is congruent to angle F. Again, they were both congruent to angle E, therefore they are congruent to each other. And then the distributive property, if you have A times the quantity B plus C, then that equals A times B plus A times C, which should also look familiar to you. So example 1 here says solve 3x equals 6 minus 1/2 x and justify each step. So we're basically going to just solve an algebraic equation here, but we're going to use our properties to justify what we're doing. So first thing that we should be doing is just rewriting our original equation. So 3x equals 6 minus 1/2 x. We're going to say that is our given equation. All right, that's where we're told to start. Now, there are a lot of good ways to solve your algebraic equations. If you want to try a different strategy than me, you're always welcome to. Just make sure you're using the appropriate justifications. For me, I like to get all my x's on one side, so I'm going to add 1/2 x to both sides. to get 3 1/2 x equals 6. So since I added 1/2 to both sides, that is the addition property. And I don't mind if you abbreviate property, but you do need to write it, because doing the addition property is different than just basic addition, right? You can just add any two old numbers you want together. Addition property specifically says you're adding something to both sides of the equal sign. Now, I don't really want to work with 3 1/2, so I'm going to change that into an improper fraction, which would be 7/2 x equals 6. Now, 7/2 and 3 1/2, those are equivalent values. They mean the same thing. So I'm going to say that that is the substitution property, because I am just replacing an equivalent value. Now I need to get rid of my 7/2. So what I'm going to do here, this can be done in 2 steps if you'd like. You can multiply both sides by 2 and then divide both sides by 7. I want to get rid of it in just one fell swoop. I'm going to multiply both sides by the reciprocal, which would be 2/7. So if I multiply both sides by 2/7, I will get an answer of 12/7. I multiplied both sides by the same value, so that is the multiplication property. What we technically just did there is kind of a proof, right? We were given something, we knew we needed to figure out what our end result was, and we justified along the way. You can actually think of each of our bits of our equation here, each of our solving parts, as kind of like if-then statements. So for example, I was given this equation. So if I'm given this equation, then what do I know? Well, if I'm given 3x equals 6 minus 1/2 x, then I know 3/2 x equals 6. If I have 3/2 x equals 6, then I know 7/2 x equals 6. If I have 7/2 x equals 6, then I know x equals 12/7. So technically that's a bit of a proof, and then we justify each of our steps using a property, which again happens in proofs. So let's look at the next example here. Justify each statement with a property of equality or congruence. First one is that angle A is congruent to angle A. Well, that's stating something is congruent to itself, so that is the reflexive property. If x plus 5 equals 16, then x equals 11. Well, if you're given that equation, then what would you do to get x equals 11? You would subtract 5 from both sides. So that is the subtraction property. If a over 5 equals 10, then a equals 50. What would you do to get from your hypothesis to your conclusion that a equals 50? You would multiply both sides by 5. So that's the multiplication property. Part D, if 2x plus y equals 70 and y equals 3x, then 2x plus 3x equals 70. Well, you were given 2 different things to start with in your hypothesis. 2x plus y equals 70 and y equals 3x. And if you notice in the second part of our statement here, we no longer have y, we have 3x, which means y was replaced with 3x or it was substituted in. So this is the substitution property. And then part E, if the measure of AB equals C and if the measure of AB equals the measure of CD and the measure of CD equals the measure of EF, then the measure of AB equals the measure of EF. So if you look at your hypothesis, both AB and the measure of EF are equivalent to the measure of CD. So if two measurements are equivalent to the same measurement, we can say they are equivalent to each other. So that is the transitive property. And then in the next video, we're going to get into some proofs.